Hey, what's up YouTube? This is my engineering model for my stairs design. It's completely vertical, as you can see. There's nothing pulling any blocks into the side. This is just a door right here. It's completely optional. So like I said, there's nothing pulling any blocks into the side. It's all completely vertical, and it's 11 blocks high. So it's not too bad as far as height goes. So we'll just get started. Um, When you press this button, it takes a minute to start opening, just because there's a T flip-flop down there, and the signal takes a little while to pass through the whole circuit, but I'll get to that in just a second. So yeah, it's completely retracted, and then you just, this is just a view from the side, and then, I just have a room here just so you guys can see, and then same thing down here, there's a button, you just press it, and it closes. And then that door closes behind it, so you don't have to see, you don't have to see the pistons when you're down here in this room, or whatever you have down here. Alright, so yeah, that's the operation of it. So we'll go over how it works real quick. And when you press this button, or the button inside is just wired up right here, and I have everything in green. That's all just the wiring for the system. Everything in green you can completely change to, you can adjust it to where you need it. You can even change the length of these or whatnot. It's just the way I have it. And this is just the T flip-flop over here to control that door opening and closing. Nothing special over there. So anyway, the signal comes down here, comes in as T flip-flop, and this provides power right here to this ABBA gate. I won't go over that because there's tutorials and whatnot on YouTube and on the forums, so you guys can just check that out. But I will go over the timings of it real quick. As you can see, I have repeaters placed down the middle, and they're all pointing towards the stairs, or towards the output. The output is down here. This is the output side of the ABBA gate. I just have these torches up. I don't even need these really. So yeah, in the middle we have just one tick repeaters. You don't have to adjust them at all. And then in the back side we have 4 ticks. I did a lot of playing around with these timings just to get them right, and this is what I came up with that always works, and it's smooth. You guys can try it, try to adjust them if you want, but this is just what I like. So 4 ticks in the back, and then 3 ticks up front. Let's look at it from this way. 3 ticks up front on the output side. So yeah, and they're pointed this way, and it basically just forms a loop, and then they come around this way and comes back around. So I'll show you real quick how this whole ABBA system works. So this is the button, and then it's gonna provide power in that sequence, and we'll call that all the way on the far right over there, we'll call that output 1, and then 2, and then 3, 4, 5, and that makes a difference. We'll go over that in a second, but I also have them labeled all here. So it applies power to these outputs 1, 2, 3, 4, 5, and that's. But then why I needed to use the ABBA gate specifically is there's the beginning of the opening sequence, but this also handles the closing sequence. So there's the beginning, the first half of the opening sequence, and then this light blue portion takes over at that point. And then after you hit the button again to close it, it comes back down here, and this ABBA gate closes it. So remember, it turned on 1, 2, 3, 4, 5. So when you apply power to it next time, it's going to turn off 5, 4, 3, 2, 1, which is very important because that's the sequence you need to close it. Let's show you again. We'll go look at the pistons this time. This is opening, goes 1, 2, 3, 4, 5 in that order, and then we'll go over this whole, all that business in a second. And then when you close it, it just applies power 1, 2, 3, 4, 5, or removes power if you look at it from the output side. Uh, so yeah, that's the opening and close. That's what this ABBA switch does. It just opens and closes it. But then in the middle of that, when you open it, I'll go over here, show you guys. When you, and this is just wired up to that flip-flop again. So when you open it, you're gonna get power 1, 2, 3, 4, 5. And when 5 down here, see it's just wired up down there. It's to those torches. When 5 gets power, this is just a rising edge detector, or rising edge pulsar, whatever you want to call it. When this receives an input, a positive input, or an on signal, it's going to provide a short pulse to this line right here. Let me show you real quick. You see that short pulse right there, and that's what operates this light blue portion, which is the second half of the opening. So this pulse comes in, goes into this block right here, and this sends a pulse right here to number 1. So just to simulate the pulse goes in, it temporarily cuts that torch off, which is providing power to line 1. So it temporarily cuts that torch off, which makes line 1 pulse, which is what you needed, because it's going to go, well, I'll go over the sequence in a second. So then it comes over, I'll put a repeater here 4 ticks, that way it's not all happening at once. So then it goes, this is basically pulsar number 2, and the power is going to come in here. After it goes through 1, it goes into 2, and does the same thing on line 2. It cuts it off. Same exact thing. And then number 3, line 3 starts right there, comes over here. This is just a little bit different design because of the way the wiring is. I had to come up with different ways to cut the power or toggle the power on these lines. So all this does is when you apply power to this, it just cuts power right there on line 3, which is what you need for the operation. And then it retracts and power's reapplied. Then it comes over to line 4. You can see it back there. It comes down through here, and line 4 does the exact same thing. It just cuts off right there. Cuts power to line 4. So it toggles line 4. And then this block right here serves 3 functions. First, I just use different repeater timings to, time out the 3 functions of it. But first, it goes back over to 2. Just comes through down here, and this is line 2. So all it does is pulses 2 again. Okay, so, and then the second thing this block does is goes over here, and then goes over and pulses line 3 again, because you need to pulse 2 and 3 again. And then the last one comes out back here and goes back over and then loops back into 2 again. So with all that in mind, that's the second half of the opening sequence. And with all that in mind, I'll go show you, and you can see it all working right there in line. But I'll go show you the sequence and why I came up with that on this model right here. There's no automated system down here. This is just an early version. But right now it's closed. As you can see, it's flush. Just imagine there's floor all around here. So the sequence for opening, and this is what the first part of the ABBA gate does. It turns on 1, 2, 3, 4, 5 in that sequence. And then remember that positive edge detector sends a pulse up to that light blue portion, and that's where this picks up. It toggles 1, and then toggles 2, and then toggles 3. So it takes power and reapplies it, and then toggles 4. And then remember, you have to go back up to 2 and toggle 2 again, and then 3 again, and then back up to 2 one more time. And that's it. That's the second half of the sequence, and the stairs are down, or the door is open, however you want to look at it. So that's what that light blue portion takes care of right there, that whole sequence. And the reason it's kind of spaghetti-like and tricky. It's just because I had to come up with something that would work, that would provide that sequence, steadily at all times. So that's the best thing that I came up with. Not to say that there's not a better design, but you guys can work on that and see if you can come up with something better. And I'll keep fine-tuning this whole system. So then after that happens, it stays like that. And then when you hit that switch again, remember that ABBA gate is going to also close it. It's going to remove power in the opposite order. So we started with 1, 2, 3, 4, 5 applying power. So we're going to end with taking power from 5, 4, 3, 2, and 1. And then it's completely closed. And it's always going to go in that order, the closing. And it's always going to, if for some reason it's messed up or something, it didn't open right, you're messing with it or something like that, closing it will always fix it, because the way you do it, these pistons have no option but to extend fully. Get some light here. And while we're here, we're just going to go over the design of the piston system itself. So it's just basically you start down with one piston, and then you extend that up, and then you're going to have 2 pistons, and you're going to have a row of 3 pistons, and then another row of 3 pistons. This is important. You can't put 4 here or 2 here. This is what works. 1, 2, 3, 3, and then 4. And then you just need to match your torches and repeaters on either side for that whole system. And that's what works. And the sequence is unique to this particular design with how many I have. Not to say that there's not another way to do it, but this is just what I fell into. I've been working on this for a couple months now. And it took a lot of trial and error to get this whole system and sequence working properly. So, alright, so with all that, we'll go back over here, and you've seen the whole sequence work, and I'll repost that opening sequence for you guys that want to, try to come up with your own automated system. I'll post that whole opening sequence in the description below, so you guys have that. And then that's it. So green is wiring, no big deal. You guys can change that however you want. Everything in yellow is just my logic gates. That's just what I did to make it easier for you guys to understand. So there's a T flip-flop there, and there's a T flip-flop there, and then there's this positive edge detector. And this isn't really a logic gate, it's more of a switch, but I kind of wanted to be blue but not the same. So it's all, because this is all one system. This right here is the brain. Everything in blue controls the whole sequence. So I just want to point out, when I do get the schematic to this whole thing uploaded, you may, I should say, have to come and redo this T flip-flop. And what I mean by that is, when you post a schematic sometimes, because these are in an on state naturally, so when you post a schematic, these are going to be pushing towards each other, so they might destroy this block right here, and you end up with this configuration. So your system's not going to work when you first hit the button. So if it doesn't work, just break one of these, and then break one of those pistons, and then place your block, and then just put the piston back, and then it'll work. And the same thing up here. You got this T flip-flop here. So if for whatever reason none of it works when you post this schematic, that's why, because that's what I figured out. Alright, so that's it. There's not much else to it. This line right here is on, and this is why I have this repeater here. Whereas you can see, I have the repeater on the other side on all these. This repeater is here to prevent the signal from going back in to the main system because of this torch right here. I could put another repeater here, but I had to put this one here because this one comes down, and it just creates a loop basically. It's just a lot of trial and error stuff really going on there. So yeah, that's about it. Thanks for watching.